Hello, thank you for listening this paper presentation. The paper title is using the XGBoost model to predict Santander Customer Trading. The following is the agenda that I will present it: introduction, related works, and the analysis model and conclusion. With the rapid development of Internet, many transactions in many enterprises can be completed on the Internet, and transactions on the Internet will leave records in the database. And we hope to help companies analyze and predict this huge data set. We use the Santander Bank Customer Prediction Competition data set. If the data set can be accurately predicted, the prediction result will become a very valuable data. After effectively using this data, companies can better understand their customers' trading habits and transactions volume, and let companies understand the operating experience. In order to learn how to analyze and predict data and to develop a keen sense of data observation, we decided to participate in the cargo competition. There are two major goals in cargo competition: predictive analysis and data classification. Santander Bank assisted clients in understanding their financial situation. Are they satisfied? Will customers buy this product? Can customers pay this loan? Regardless of the transaction amount, will the customer conduct the transaction? I think that's all we can try to help. Cargo has data science teams from all over the world that constantly challenge machine learning algorithms and cooperate with the global data science community. We will also participate in it and refer to different analysis models to ensure that we can more accurately solve the difficulties encountered by enterprise. Binary classification questions such as: are customers satisfied? Will customer buy this product? Can customer pay this loan? In this challenge, we will determine which customer will conduct specific transactions in the future, regardless of the transaction's amount. We can use the data we predict to judge and analyze and reach the expected transaction. This is the table that we use the prediction tool and model. About the related words, we have the following, like decision trees, SVM, and XGBoost. This is decision tree. Decision tree is proposed by Hunt and his colleagues in 1996. It is a tree branch concept to be a decision tree model. This model also almost used in classification prediction, which is divided into classification tree, regression tree, classification regression tree. For the SVM proposed by Corina Court and Vapnik in 1995, mainly classifies binary data and divided into two categories based on the principle of minimum classification error rate. SVM used the current data as training, selects several support vectors from the analyzed training data to represent all the data, removes some extreme values, and packs the selected support vectors in a model. For the ANN is a mathematical or computational model that simulates the structure and function of the human brain, and it's inspired by biology. Each neuron is connected to other neurons and will be impacted by the state of other neurons, thereby determining whether it will fire itself. N is a black box model that can find the relationship between input data and output data and form a pattern of to make prediction on different input data. For the last is the XGBoost, referred to as the XGBoost, was proposed by the promoter Chen Tianqi in 2014, which means the XGBoost models is developed in C++ of the gradient boosting machine. Boosting belongs to the overall learning classifier, which classifies many classifications with low accuracy. For our data set, the data set comes from the data center in the Chicago Santander Trading prediction competition. The competition data is divided into three parts. The first part is the training set. The second part is the test set, and the last part is the prediction result set. The training set data can be used for data pre-processing and visual design and modeling. When the model is created, the processed training set is used to predict the data in the test data. And finally, the prediction result data is generated. This is the table 2 and the table 3. It shows the training data attribute and also the test data attribute. For the data analysis is so far used to 2 models, 3 models and 4 kits. First, the model uses the XGBoost model and the random forest model, and the model are the CSV model, non-PY model, and Sklearn model. Finally, there are pandas suite, plot library suite, Sanbone suite, and OS suite. For the following is introduction to these models. We shortly introduce these. Like the first one, the XGBoost model. It used to predict the accuracy rate. For the following is there are 6 elements. The first one is max depth parameter. Is the maximum depth. The greater the depth of the tree, the higher the degree of overfitting to the data, which is used to predict the fitting problem. The second one is an estimator parameter, the number of trees, which affects the training speed. The larger the model, the longer the training time. The third one is column sample by tree parameter, the ratio of random sampling of features. When the tree is established, if the ratio is larger, each tree is more similar. If the ratio is smaller, the diversity of the tree can be increased. The first one is learning rate parameter. For the learning rate, the larger the value, the faster the model learns the training set. If it is too small, the training is too slow. If it is too fast, the advantage is missed. For the fifth is object parameter. The binary logic parameter is used for the logic regression of the 2 classification, which returns the predicted probability, not the category. For the sixth is the n-jobs parameter. How many CPUs are used for execution? For the second one is random forest models. It also has 6. For this model, there are 6 elements in the random forest model. The first one is an estimator map parameter. The second is random state parameter. The third one is max depth parameter. The fourth one is mean sample length parameter. The fifth is criterion parameter. The sixth is max features. For the third one is the model that describe about CSV model, and also the NUM-PY model, and the third one is scaling model. So we also use the pandas package, supports multiple text and the data loading, and can quickly understand the data structure. So we can read about, you can see that we have the 6 elements of that is read CV, panda information, pandas shape, pandas head, and pandas is newer sum describe. And also we have to how to build the charts and use this NUM-PYs. So we use the matplot library to use this to make it as building the charts. So like we can see the plot feature scattered for the programs, and also we have some definition and the about some description in that. So we can draw the figures like this one, the figure 1. For the distribution difference is not obvious. We also use the Santander suite. It creates some charts that is more powerful than the previous one, matplot library suite. So you can see the figure 2. It shows that the training set and test set comparison. For the correlation is high. So we can use this to some figures and some visualization to help us to judge that if we have similar to the test data and the training data. So there are the following 16 steps are used for data analysis. The first one is confirm purpose data. The second is data collection, and then is data pre-processing, and then is data exploration and visual design. And also we have the model establishment, model evaluation, results presented, data pre-processing, model establishment, model evaluation, data pre-processing, model creation, model evaluation, building the model, model evaluation, and the last one is results presentation. So we use this to for the prediction accuracy for after model training. In order to check whether the model has overfitting problems, we use visual analysis to evaluate the model and continuously modify and adjust parameters. This chapters will introduction. We the use parameters, show metrics and classification reports of each model. So the figure 3 shows the prediction accuracy flow chart. We have 40,000 data. We separate it with 2, divided into 2. The first one is 75%. This is the target, and the second one is the 25%. And use that the 70